Welcome to Let's Talk Chemistry with Pastor Dan. We're looking at chemistry. We're continuing our process. I believe this is day 6. We're looking at metric units, and I cover the metrics because it's a system that we use that's based on multiples of 10. Now, in the English system, we do have the English system, which we can use, but the units are all over the place. 1 mile, 5,280 feet, 3 feet in a yard, 16 ounces in a pound, 32 ounces in a quart, 4 quarts in a gallon. It becomes problematic. Having a system constantly based on the number 10 works best, and that's why we use the metric system. Now, in the metric system, we have length in meters. We're going to go through each of these as far as what they mean and how they work. We have volume in liters. We have mass. Scientifically, you can say grams. We'll talk about how they actually measure them. And temperature is in Celsius or Kelvin. And time is in seconds. All right, so let's go through the first one. Before we do that, though, I forgot to mention this prefixes. Now, there are a bunch of prefixes in the metric system. For my class, when I teach, I only make my class know 5. Okay? Hecto, tera, all those things, those are cool, they're good, but we're not going to use them enough in order to make it necessary. So the prefix you actually have to know. Kilo means 1,000 of. So a kilometer, 1,000 meters. A kilogram, 1,000 grams. 1,000 of. It's the only one that I make my class need to know that is larger than 10. All right, deci. Deci means a tenth of. And the way to memorize that, think of a decade. How many years in a decade? 10, a tenth, deci. Good. Centi. Centi is 100th. Again, think century. So centimeter is 100th of a meter. Milli. Milli is 1,000th. Think of millennium. 1,000 years of millennium. 1,000th of a meter is a millimeter. When it gets really, really, really small, that's a billionth. 1 with 9 zeros. We'll talk about light. We'll talk about nanometers. And nanometers, there are between 300 and 700 nanometers in visible light. We'll talk about emissions, wavelength of light, energy. So those are the prefixes that we actually need. Now, for length, we talked about meters. Now, things have to have a specific thing we can always look at. So when we look at the meter, the way we come up with a meter is it's a wavelength of krypton light. When we get light from the starting point till it starts up again, that's 1 wavelength. The length of that is exactly 1 meter long, okay? So that's how we come up with the meter in length. Now, that's krypton light. Now you're going, wait a minute, krypton's green. No, krypton, gas, electrified, is a purplish color. Unfortunately, the makers of Superman, while they make great comics, weren't good scientists. Krypton, not great. All right, now if I was to make a measurement here, way that I do this, I take a point. Let's say let's do little L here. Oh, an L, not an I. All right, and I'm going to put that right, if I can grab hold of it, right there. Slide it all the way over here. Let's say I'm measuring right to this point. How would I measure that? Well, I start with 50. So I tap out 50. Now I count the lines. I have 1, 2, 3, 4 lines. So it's 5.4. Now I can make an approximation. I'd say that right in the middle. So it's 5. And the units here would be centimeters. So this here, that line right there would be 50.45 centimeters. Most meter sticks and rulers go to 2 decimal places when we're making measurements. All right, we get to volume. Volume is a liter. So a liter is 1 cubic decimeter. So if I took and made a box like this, not too bad when it comes to like actual. There we go. Try me. I don't want to try to draw this. This would be a mess if I try to draw this. There we go. And if I make this exactly 1 meter on a side, 1 decimeter side. So if this was 1 decimeter, like that, and clone it, and rotate it, 1 decimeter right there, and then clone it, and make it like that, and 1 decimeter right there. Decimeter times decimeter, decimeter, a cubic decimeter, that's 1 liter. Now, the substance we use to measure it is a graduated cylinder. Graduated cylinders, they have a principle. This little line here, do you see how we have this? Let me get a marking pen. How we have this line go slightly down here, like this. Okay? We call that a meniscus. Okay? Oops, no V in there. All right, it's the it doesn't like that. There we go, meniscus, it's an E. All right, so the way that it's caused is because of adhesion. Glass pulls up slightly on the end. So how will we measure this? Well, here's 50, 51, 52, not quite 53. So this would be 52, and I'd say that's pretty close to 53, but not quite there. 52.7 maybe, and the units are milliliters. So we have 1 decimal when you're using volume with graduated cylinders. So that's how we measure that there. All right, we go to mass. Now, mass is a gram. The way we get a gram is we take a cubic centimeter of water and put inside of that's exactly a gram. You go to Europe and say, all righty, how do we use this? It's a grams as standard unit. They'd laugh at you. Why? In most of Europe, most metric countries, a kilogram is actually what a standard is. Now, I weigh like 197 pounds, 197 pounds. If I was to convert that into metric into grams, I multiply that by 400. I would weigh 89,438 grams. That sounds massive, okay? And that's why we don't use grams standardized. So we would say that would be 89.4 kilograms. That sounds a lot better. I used to have my classes use this thing. This is a triple beam balance. Those have fallen out of most scientists, even I in my small schools district, we use electronic balances. You just put it on there, you zero it, you can read it. If you were to measure this with the way this is set up, you start with the largest number first. So we get 130 here. So this would be 130. Now the numbers here, we see we went to 5. So 135. Now we're looking at this number line right here. We're not quite on the 6 line, so we're just beyond it. So 6, 2, and then we're going to be grams there. So that's how we'd use a true beam balance if we still use them. A lot of places use electronic balances, but that's how we measure them. And masses almost always get measured to 2 decimal places. All right, now for Celsius. Celsius is a unit for thermometers, for temperature. We're going to use, boiling point is 100 degrees, freezing point is 0. We have a scale that we can use, which is Kelvin. Now, Kelvin is an absolute scale. What does that mean? It starts at 0. See, temperatures take place because of vibrations. The more vibrations you have, the greater the temperature. The less vibrations you have, the less the temperature you have, till you get to 0 Kelvin. Now, it's not degrees Kelvin, it's just Kelvin. Can you get to 0 Kelvin? Well, you'd have to have something colder than 0 Kelvin, and you can't, so you can get close. We've gotten to like 0.00004 Kelvin through pressure techniques and using radioactive process like blowing over top of a cup. Those are ways we can get to really low temperatures. But we can't ever get to absolute 0 because you'd have to have something colder, and you can't have colder than absolute 0. The way we get from Celsius to Kelvin is we have, what was that? We go, there we go. and do a conversion. Now, it's actually 273.15, but we're going to make it close enough, 273. So to convert from Celsius to Kelvin, I add 273, Kelvin to Celsius, I subtract 273. That's the way we work it. Now, one last concept I want to talk about before we finish up here is precision and accuracy. All right, these sound a lot like the same, but they're not. Precision is a close measure to previous measures, so constantly getting the mark over and over again. Accuracy is closeness of a measure to a correct value. And if we can only have one, we can have precision with accuracy or accuracy. Which is better? And most of you are going to go, well, accuracy. Obviously, accuracy is better because you want the correct answer. Well, let's do an example. Okay, let's say we have a target here, and I get X. So I get one shot with my X, and I get it here. Is that very accurate? No, not at all. Second shot, let's say I'm right here. Again, we're getting better, but still not accurate. Third shot, we put it right here. Man, that's dead on. All right, now, if I didn't know where the target was, and I'm just taking shots, and a lot of time when we do stuff in labs, we're getting values. We're not sure what the answer is supposed to be. Without looking at this target, do you know any of these are good? No. They're all over the place. The fact that you probably hit that bullseye dead on, that's more blind luck than actual skill. So this is an example of accurate without precision. Now, if I have precision without accuracy, it would sort of look like this. Okay? So I have three scores, all tightly massed together, all right inside of there. Now, is this accurate? Not at all. But we're doing the same thing over and over and over again. We're missing the target, but we're being consistent in our process. So if I only have one, accuracy without precision, precision without accuracy, I want precision without accuracy because this is saying I'm doing the same thing. I'm not doing it right, but I'm doing the same thing. If I'm any good as a teacher, hopefully I am, I can eventually teach my students how to get better with their process and get better accuracy. So being consistent in doing measurements the same way, precision is what we prefer. So if we only have one, precision without accuracy, accuracy without precision, that's what we have. So can I talk to you a little bit more about one thing? All right, now we're going to do a little bit by hitting the mark. That deals with something called sin. Now, I know sin is not something that is overly desirable to talk about. People don't like, well, it's uncomfortable. We're sinners. We're all sinners. And the actual Hebrew word sin basically means missing the mark. That's what we do when we sin. What's the mark? It's what God set as a standard. How? How did he set the standards? Well, he gave us his laws. He gave us the 10 Commandments. And when we don't do what God has asked us to do, we miss the mark. That's why we need grace. That's why we need forgiveness. But that's why we endeavor to do better, to follow after him. And we can't do that. There's no way that we can try to live better on our own. We can only live better as we live closer to him, in a relationship with him. When we get to know him, we know what he wants. And if you try to do it by religion, by just doing the same thing, to grunt it out, to force it out, you think you're doing good, but you're doing it on your own efforts. And Paul would always say that's like stinking rags. It's gross. It's disgusting because you're not good enough. You never will be. But only as we're in a relationship with him. I have come that you have life and life abundant. That's what Jesus said. And it's about the relationship with him that teaches us how to live that life, how to be better, how to focus on him and what he wants. So that's what we have as far as measure. We'll never measure up on our own, but with his help and by God's grace, the Holy Spirit, we can do it. Hopefully that wasn't too bad. We're going to talk about conversions tomorrow. So hopefully that helps out. Take care. Be good. Bye.